Hello, my lovely chemists. This is question 7, Mrs. Baker's monster paper, paper 4, module 12. So, flavorium, Fl, atomic number 114, was first made in research laboratories in 1998. Flavorium was made by bombarding atoms of plutonium, or Pu, with an atomic number of 94, with atoms of element Z. The nucleus of one atom of plutonium combined with the nucleus of one atom of element Z. This formed the nucleus of one atom of flavorium. Suggests the identity of element Z. Well, it's already given us enough information. It says that the atomic number of flavorium is 114. It says that the atomic number of plutonium is 94. So the difference between 94 and 114 is 20. So what we're looking for is an atom of nucleus is 20, because what it says here is that the nucleus of one atom of plutonium, well, the plutonium was the one that had 94, combined with the nucleus of element Z plus 20, which made the atom flavorium, which is actually 114. So look on your periodic tables, which element has a nucleus that is made up of 20 atomic mass units. So it's got its protons and neutrons combined are 20. Well, that would be calcium. In which period of the periodic table is flavorium? Well, if we look on our periodic tables, it actually shows us that flavorium is there. It's in group 4 and it's in period 1, 2, 3, 4, 5, 6, 7. So we only need to look on our periodic tables and bring that information across. Predict the number of outer shell electrons in an atom of flavorium. Well, it's in group 4, so it's going to have 4 electrons in its outer shell. Thank the Lord for the periodic table. 2 isotopes of flavorium are 286 flavorium and 289 flavorium. The nuclei of both of these isotopes are unstable and emit energy when they split up. State the term used to describe isotopes with an unstable nuclei. They are called radioisotopes. All one word, but they're called radioisotopes because they are radioactive. So complete the table to show the number of protons, neutrons, and electrons in the atoms of the isotopes shown. Well, it tells us up here that we've got 2 FLs. The mass number of one is 286, and the mass number of the other is 289. And we know up here that both have a proton number of 114, because it tells us at the top of the page. So the number of protons in both of them is 114 because the number of protons never changes. They're both atoms, so the number of electrons must equal the number of protons. Now all we need to do is do a sum to take away the mass number from the number of take away the number of protons from the mass number. So 286 minus 114 is 172. 172. Hope my maths is right. And so if we've got 3 more, we must have, on the other isotope, we must have 175. Only a relatively small number of atoms of flavorium has been made in the laboratory, and the properties of flavorium have not yet been investigated. It has been suggested that flavorium is a typical metal, suggests 2 physical properties of flavorium. So you can have so many here to choose from. I'm just going to choose immediately high melting points, because all metals have a high melting point, and I'm going to choose good conductor, because they are the 2 obvious ones. You could also have shiny, sonorous. You could have malleable and ductile. You could have hard or dense. because it's going to have all of those classic transition metal properties. So just one chemical property, I would say it forms basic oxides. It forms basic oxides because all metals form basic oxides. That's a chemical property of the metals, whereas all non-metals form an acidic oxide. That, I think, is the end of question.